In today's video, we will be taking a look at how 3D models are created, the industry standard software used, and how an asset is prepared for the next steps, such as texturing and animating. Autodesk Maya is the program generally used for CGI in films. We can do pretty much everything CGI related in Maya, and as such, basically all VFX houses use it. But, as with all programs, it has its strengths and weaknesses. Its strengths being modeling, animating, and rendering, and weaknesses being pretty much everything else. Okay, let's get started. This is my 3D workspace where all the magic will happen. As I am recreating an existing model, I first bring in some reference images I found on Google. I set up the image planes on the three main views, align them to the center, and move them out of the way. Once I'm done with that, I can just model over these, and that way, I get the exact shape I need. In the top left, you can see the primitive shapes we can add to the scene, and they tend to be the basis for everything. I add a cube to the scene, then use a variety of modeling tools to modify the vertices, add, shape or delete faces and edges, and generally shape the mesh. Because Mjolnir is very symmetrical, it is enough to create just one corner of it, then duplicate that around and then reassemble the geometry. This technique is used a lot as it can vastly reduce the workload and can ensure that symmetrical things are, well, symmetrical. There we go, all back together. A thing about modeling, especially in Maya, is that n-gons, in other words, faces with more than 4 sides, are a no, so we must avoid them. Triangles are not our friends either. Instead, quads are what we aim for. It is important for edge flow, UV mapping, rendering, and good topology. Another thing is sharp edges. Nothing in real life is as sharp as a perfect angle in 3D, so we always have to bevel the edges. Otherwise, the sharp break in the light reflection will immediately give away the fakery. Lastly, we add the 2 circular shapes. Circles in squares, and especially squares in circles, are a tricky thing in modeling, because smoothing happens sort of automatically, so our topology has to be really good to keep things neat when we subdivide. Time for the handle, for which we use a cylinder to begin with, and just like with the head, we select Move and Reshape. To ensure that the gold rings are equally spaced, we can insert multiple edge loops all at once. Bevel Extrude. Again, it's important to bevel, so we take the time to select the edge loops one by one and do just that. And that's it, modeling done. However, we are not done yet. There is one more stage called UV mapping, and we need to do that for texturing. When modeling, we are working in X, Y, and Z space. And when we're done with that, we unfold the 3D model into 2D UV space, so we can apply a 2D image to it. This will then correspond to the 3D coordinates on the model. Essentially, we slice up and flatten out the model, and the faces in 2D will represent the faces in 3D. So when we add an image in the 2D area, it will color the same faces on the 3D model. We can use the cut and saw tool to cut up the mesh as if it were a paper model that we want to flatten out. This is the actual UV space. The challenge is to lay out all these UV shells into one of these squares using as much of the available space as possible. We need that because the bigger the shells are, the higher the resolution of the image applied to it is. Obviously, if we use 50% of the space of a 2K image, then we really only have 1K resolution. That checker pattern shows that the shells are nice and optimal and not distorted, in which case the squares would stretch out. Additionally, we should lay out the shells in a way that similar material are grouped together, so that when we create textures, it will be a bit easier to add masks, which we will cover in the next video. And that is it. We are done. Thor's hammer modeled with good topology, good edge flow, and nice UV layout. In the next video, we will cover texturing. So we'll create the colors and materials as well as a simple shader network.